probably the easiest way around it. So, two variables, x and y, are in direct, non-linear proportion if y is proportional to a power of x rather than just x. Okay? The variation function is still just y equals k x to the power of y. So that doesn't change. This symbol still gets replaced by equals k. All right? Why can't k be 0? That's your notation from the first unit, isn't it? K is not allowed to equal 0. Why is that?
I don't know how to explain it, but like you can't go up in 0, you can't.
What's k? The
Constant.
so that's the thing that you multiply one by to get the other, right? So if k is 3, 1 times 3 gives you 3, 2 times 3 gives you 2. If k is 0, you can't do 1 times 0 where you get 0. 2 times 0, it would be everything is always 0, which is not a direct proportion. So that's why that n has to be greater than 0. So n is the exponent. Why does n have to be greater than 0? It's not the same reason, unfortunately. That would be too easy. Anyone know or Ben?
There's like 8 to the power of 1 is just 8, but 8 to the power of 0 is something else.
What is 8 to the power of 0? You should know this. Anything to the power of 0 is. Someone said it.
1.
1. Anything to the power of 0 is 1. What's x to the power of a half? X to the power of a half is the same as square root. X to the power of a negative number would actually turn it into inverse proportion. So that's something that maybe we still need to know. Okay, so just look at this again. This is on your sheet. You can now. Kx power of n is a relationship, direct relation. When x is multiplied by a constant, then y is multiplied by c to the power of n, not just the same thing. Alright? So that exponent and the constant go together. Let's have a look then. So this is quite a normal one to look at, especially in physics. So the light intensity, does anyone know how light and distance are related? Anyone already looked at this? So we're talking about if I shine a torch, if it's not a laser, it's just a torch, does it stay the same intensity? So you shine a torch out into the night, can you see as far as you want? The light suddenly fades, doesn't it? You can't see. Does anyone know what that relationship is? Yeah? Well, this is what this is about. Okay, so it's a common. So when the screen is, you'll need to be writing down. I guess I've not left much space underneath, but maybe you can do this in your book and then reference the sheet. So when the screen is 3 meters from the projector, the light intensity is 24 units. I don't know what that means, doesn't matter. Find the light intensity when the screen is 6 meters away. So it says here, the light intensity on a movie screen varies inversely with the square of the distance. So how would I write that? I've got to define my variables first. All right, let's define the variables first. What would you like to call light intensity? L? Okay. Capital L, light intensity. What do you want to call distance? D. Okay. How would I write intensity varies inversely with the square of the distance? L, fishy symbol. 1 over d squared. And that's it. Okay? Now I write an equation which is L equals what? A over d squared. Remember the fishy symbol becomes equals k. K times 1 over d squared is k over d squared. We talked about that. Right, so now we've got the same thing that you had on that dancing page. How'd you get on with the homework, by the way?
Oh.
Did you finish it? Yeah?
Well, I didn't finish it. I
You did your 15, 20 minutes. And you all understand. So when we do it now, you're all good. Okay? So when the screen is 3 meters, the light intensity is 24. So I'm going to write that. So when D equals 3, I equals, sorry, I said I, but you decided it was going to be is 24. What can I do with that information? Substitute. So we do so what's K? 24 multiplied by 3 squared or 9. You can do that. K is okay. So now I've got my formula. So now I've got L equals 216 divided by D squared. That's my formula. It says, find the light intensity when the screen is 6 meters away. So we're asking, what is, again, not I, we want it L. L when D is 6. Okay?
16 over 6 blue.
So L equals 216 divided by 6 squared.
L equals 6.
That's right. $216 divided by 36. 6. Okay. Let's just, well, actually, let's read the rest of the question. So, are you okay? What I've written is not the clearest. I've written along instead of down for whatever reason. Says, describe what happens to the light intensity when the distance between the projector and the screen is r. So what have we done so far? We went from 3, right, so there's, and that's L, we went from 3 to 6, and light intensity went from 24 to 6. So if we double the distance, we divide by 4 or 2 squared. Remember that? So because it's a squared, same thing again with inverse. If I times by 2, the other one is still divide by 2, but divide by 2 squared because of this thing here. Yeah? That gets applied to the other side. So, for instance, if I go from 6 to 3, so if it's 6 and 3 and 24, I do it the other way. So if I divide by 2 on this side, it's times by 2 squared, which is what happens, yeah? And that's it, that's the only real step up. But we can square, we can cube, we can square root, we can do things like that. Okay? Where do you think the biggest mistake in a question like this would come from? Yes? What about it? Yeah, it is exactly that. It's just remembering to square it, actually. That is the most common mistake. Should we write that down? It's always good to know mistakes. Most common mistake, okay? Forgetting the exponent. Alright? Whether that's a squared, or a cubed, or a square root, or whatever, forgetting the exponent is the biggest common. And if I give, well, when I give you an assessment on this, I think we've got away with doing the surds one, I'm not going to bother with that. But we'll definitely have an assessment on this direct and inverse variation. I'm pretty sure someone will forget to do the square. Why is it easy to miss the squared bit? Because what do people do when they read the question?
They don't read it properly.
They don't read it properly. They just read light intensity varies inversely, distance. That's what they do. Yes, Samantha?
I'm a little bit sure. Are we doing square because it's new?
No, it says here, with the square of the distance. It tells me in the question. Yeah? So, for you to practice that, we just did example 4. Right? They've gone through it. However, more complex, I think. Wasn't really. I've not asked you to graph it, but that is the next stage. It says, well, actually, let's have a look at part C. The distance between the projector and the screen is increased by 25%. Screen is increased by 25%. Find the effect on the light intensity of the screen. But this is an important one, actually. So how would you do that with no numbers? Let's write that down. So we've got, it's not right, L equals 216 over D squared. Okay? What do we say? D is increased by 25%. What happens to L? Any guesses? Yeah.
Increased by 25% squared.
Makes sense. What's 25% squared?
Oh, it's a lot more. So
25 times 25. So you got his calculator out.
25.
Yeah. So we think if it increases by 25%, the other one decreased by 25% squared would be a decrease of 625%. Well, actually, that depends on how you consider an increase of 25% or a decrease of. So how do I do a decrease of 25% squared? Is that 625%? Or is it something else? Yes. Okay, so let's have a look at, there are no numbers, but could we just chuck some numbers in and see how it works? All right, so for instance, let's come up with, this is an exam tip, by the way. This question, we don't need numbers, but if you're a little bit confused, let's put some numbers in. All right, we've got D is related to L. Well, let's pick one that's nice and easy to increase by 25%. Give me a number for D that I can increase by 25% easily afterwards. 4. Okay. 4 or 40 is a nice number. Right? What would an increase 25% end up being? 5. Okay, so we've done that in our heads. That's nice and easy. Right? Can I get you to work out the two L values? Go for it. So we put 216 divided by 4 squared is not 8. Which is? Okay. And then this one would be 216 divided by 25. 6. 4. Okay, did you have to round? Exactly 8.64. Cool, that's good. Alright, now here's the question. Do you remember when we looked at it before, this was times by C? What was it on this side? Was it a times?
Divide.
It was divide by C squared because of the square. So, let's just confirm. What do we multiply by to increase by 25%? Just been doing it with my M1s. 1.25. We actually multiplied by 1.25. So, should we just check? If we multiply by 1.25 squared, can you do that? 13.5 multiplied by 1.25 squared, does it give you 8.64? Oh, sorry, divide, isn't it? Not multiply. I keep saying divide.
8.64, 8.6.
Yeah, it works. Good job, really. If it doesn't, you've done something wrong. Can we just confirm it? Can everyone do it? 13.5 divided by 1.25 squared should give you 8.64 if we're following that rule. Does it?
Yes.
Okay, let's just work that out then. Times in by 1.25, okay, is an increase of 25%. What's dividing by 1.25 squared? Well, let's do that. What is 1.25 squared?
Two five.
Does that help me? Is it a percentage increase or is it a percentage decrease? It's a decrease. So let's figure that out. Again, I'm doing this currently with my M1, so I know you've done this before. 13.5 times by, because that's how you do a percentage increase and decrease. So I'm going to say P for percentage equals 8.64. So what is P? What's the percentage? No. You just do it. How do you work it out? Do we do 8.64 divided by 13.5 tells me what P is, no?
Yeah.
No. 13.5 is decreased by a percentage. Therefore, I multiply. Bear with me. What is the percentage? What's the decimal? 0.64. Okay. What is the same as multiplying by? So timesing by 1.25 is an increase of 25%. What does timesing by 0.64 do? It's a decrease of why, so this is going back to absolute basics. Why is timesing by 1.25 a 25% increase? So you're actually finding 125%, no? Yeah? 125% as a decimal is 1.25. So if I multiply by 0.64, I am finding 64%. Now if I find 64% of something, have I got more or less of it? Okay, is it a decrease? How much have I decreased by? 36%. So actually, dividing by 1.25 squared has done a 36% decrease. So in this case, an increase of 25% on D did what to L? A 36% decrease. All right. Tough question, but not beyond your limits. I mean, it shouldn't be. Okay. What's the same thing as dividing by 2? Multiplying by 1 over 2? Yeah? What's the same thing as dividing by 3? Multiplying by? What's the same thing as dividing by 7? 7. What's the same thing as dividing by 13? Timesing by 1 over 13. What's the same thing as dividing by 1.25 squared? Just do that for me. Instead of doing this, can you just do, what is 1 over 1.25 squared? Can you tell me what that is? It's a decimal. Can you all do it? That have got us there a bit quicker.
Yes.
Why would it be 1 over? Well, do you remember I talked about inverse relationships? If you multiply one side, you divide the other, but direct relationships are multiply and multiply. But do you remember when we first did inverse, the line of it is actually that, I wrote it up here, I can go back to that in a sec, that, oh, where did I put it? L is directly proportional to 1 over d squared. So we can actually, instead of doing multiply, divide, we could do it as
Multiply and 1 over.
yeah, so let's do 4 and 5 again. If that is multiply by 1.25, even without knowing the numbers, it's going to be multiplied by 1 over 1.25 squared, which we know is 0.64, which is a 36% decrease.
You get 37.
Because if I find 64%, if I'm left with 64%, I know it's a decrease of 36%. 100, minus 64%, or even it should be 100 minus the 36. Right, ladies and gentlemen, this is still recording, so I've recorded this. If in any way that was totally confusing, what are you going to do tonight? I'm even going to start doing what I've just been telling you, everything on ManageBack. So I'm going to put that on ManageBack as a task, so that when your parents say to you, is there anything? You can say, no, I understand it, and they can go, oh, well, I see you're supposed to have reviewed. Let's just check that you. Okay?